All right, so here is our part 2. We're going to cover the second form, which is our intercept form of the quadratic function. So our intercept form looks like this. It's y equals a x minus p times x minus q. All right, so there is our intercept form. And the reason why it's called our intercept form, just like how the other one was called our vertex form, is because we have the x-intercepts given to us. In this case, P and Q are our x-intercepts. So whatever those numbers are going to be our x-intercepts. So P comma 0 and Q comma 0. All right. And let's go ahead and graph what that means. So maybe I have a parabola that looks like this. All right, so here is my P comma 0, and here is my Q comma 0. All right, and we can also use this information to find our vertex. Now, the first thing maybe let's find is our axis of symmetry, because our axis of symmetry is the x value of our vertex. If you notice and I kind of drew it a little crudely, but if you notice, our vertex is halfway between our x-intercepts. And that's always, always, always going to be the case for parabolas. And again, that's because our parabola is mirrored across the axis of symmetry. So whatever our axis of symmetry is, all the points on the left are mirrored to the points on the right. So of course the intercepts, the x-intercepts, are going to be the exact same distance apart from each other across the axis of symmetry. So our axis, in conclusion, whatever all, you're probably just like, okay, we'll get to the point. Axis of symmetry is halfway between each of our x-intercepts. So then how do we find something that's halfway between? Well, a fancy name for that location is the midpoint. And you find midpoint by adding the two numbers and dividing by 2. It's also known as the average, right? So our axis of symmetry is given by P plus Q divided by 2. Take your x-intercepts, add them together, and then divide by 2. All right, so then we know that the x value of our vertex is P plus Q divided by 2. So then just like with the negative b over 2a, our y value is whatever we get when we take that P plus Q over 2 and plug it into our function. Okay, remember that this notation right here is just the mathematical way of saying take whatever you got for the x value and plug it into the function. Plug it in for x up here. All right, so let's see that. Let's try that together. Okay, so here's our first example for this. We want to go ahead and graph x minus 3 times x minus 7, f of x equals. So the very first thing we're going to want to do is, find exactly what's given to us, our x-intercepts. So that's our first step when graphing these kinds of functions. Step 1, x-intercepts. And in this case, it's directly the form. It's x minus p, x minus q. And I guess actually technically the step you should do before this is like our first step in the vertex form is identifying our coefficients. So a is 1 since there isn't one there. Since there isn't a coefficient there. P is 3, Q is 7 because the minuses carry. So if the minuses are there, we're taking the opposite. So if this is a negative 3, then our P is positive 3 because of the way that the form is written. So then our x-intercepts are 3, 0, and 7, 0. So let's plot those. 3, 0, and 4, 5, 6, 7. Sorry, I had to count that out. 7, 0. Okay, now our next step is to find the vertex. And then, just like last time, in one swoop, we can find the vertex and the axis of symmetry. All right, so we do that, remember, by doing our P plus Q over 2. So what is that? That's 3 plus 7 over 2, 10 over 2, 5. So our axis of symmetry is x equals 5. So we know, here's 5. So we know it's going to cut right here. And we know our vertex is somewhere along this line. Now we just got to find it by plugging 5 into our function. So we're finding f of 5, because we know the x value of our vertex is 5. So we get 5 minus 3 times 5 minus 7. Well, 5 minus 3, that is, 2, not negative 2. 5 minus 7 is negative 2. 2 times negative 2, that's negative 4. So then our vertex is 5 comma negative 4. Okay, so we go to 5 down to negative 4. Here is our vertex, okay? And, in the past cases, we've used 5 points, but we really don't need all of those. It was just nice to have. And you'll find out with this one, if we try to find our y-intercept, it's actually at 21, so we can't even graph it. But this is enough information to give a pretty nice, okay picture. So again, your guys' parabolas are probably gonna look better than mine, so bear with me. Okay, there is our parabola. And with the intercept form, I do kind of want to go ahead and do one more example with you, just because I'm not sure if you guys have seen this form before. So I just want to go ahead and do one more example. And then also because I want to do one where their A is not just 1. A is a different number. Okay, so same thing for the first step. We want to identify our A, P, and Q. Our A is negative 2 in this case. Our P, notice how it's plus, but we want x minus P, so this should be the opposite. Negative 3. And then our Q is positive 1. Q is equal to 1. So then our x-intercepts are negative 3 comma 0 and 1 comma 0. So negative 3, positive 1. And now our second step is to do our vertex and axis of symmetry. So then for our axis of symmetry, remember it's just again P plus Q over 2. So that's going to be negative 3 plus 1 over 2. Negative 3 plus 1, that is negative 2 divided by 2 is negative 1. So we know our axis of symmetry goes through negative 1 on the x-axis. And now let's find the y value. F of negative 1. So here's negative 2, don't forget that negative 2, times negative 1 plus 3, times negative 1 minus 1. Okay, now maybe you have the urge to distribute the negative 2. You could, definitely, but it might be easier just to find these first, and then just multiply everything together. That way you don't have to worry about any distribution. Negative 2, negative 1 plus 3, that's positive 2. Negative 1 minus 1, that's a negative 2. Negative 2 times 2, these first two right here, that's negative 4. But then times this extra negative 2, that's going to be positive 8. All right, and so all the way up here is our vertex. And that matches up, right? We have a negative in the front. The idea of our A being bigger than 0 or less than 0 affecting the way it opens still stays with both of the forms, okay? If A is positive in our vertex form, it still opens up. If A is positive in our intercept form, it still opens up. And then vice versa for when A is less than 0 or negative. It will open down in both of those forms as well. Okay, cool. We got our parabola. Let's go ahead and graph it. Parabola that opens down. In this case, it's a little skinnier. And again, the reason why is because of that 2, right? Whenever we multiply by a number bigger than 1 outside, then our graph gets skinnier. Sorry for the ugly parabola. Okay, hopefully that sounds okay. And I will go ahead and meet you in the next video. Actually, just kidding. Let's go ahead and do, yeah, we'll have time for this. And then one quick last video, okay? So I'm kind of throwing two more forms at you guys, the vertex form and the intercept form. It's kind of important to understand that even though they're different forms, they're still representing the same quadratic function if I write them in standard form. Okay, and this is kind of like when I take my linear equation that's in slope-intercept form and I rewrite it in standard form. In this case, I can do the same thing. Now, if I want to write these in standard form, there's kind of a different process for both, but in both cases, you're kind of multiplying a bunch of stuff out. First case for the going from vertex to standard, what I want to do is if this is squared, remember I can rewrite that as negative x plus 6, x plus 6, and then with this plus 10 out in the front. So then when I multiply this out, I can distribute. Ooh, that's not where you distribute though. Sorry about that. You know, x to x, x to 6. So I get negative x squared plus 6x plus 6x plus 36. And I still have that plus 10 on the outside. I still have the negative outside too. X squared plus 12x plus 36 plus 10. Now this negative out in front, that's like a -1, so I can distribute that to everything on the inside. So I get negative x squared minus 12x minus 36 plus 10, and my last step here is to combine my like terms. So I get f of x is equal to negative x squared minus 12x. Negative 36 plus 10, that's negative 26. Okay. So notice that the a here was -1. The a here, you know, ax squared plus bx plus c, the a is still -1. So all those a's that you've seen in all the forms, they're all the same. Okay, the only letters that we're changing are the b and the c, h and k, p and q. All right, so there's our answer. And then here is one more for going to standard form. This one's kind of the same idea. We're going ahead and multiplying out this part first. We can go ahead and distribute the 2 immediately. It's really up to you if you distribute this and then multiply into the x plus 3, or if you multiply the x plus 4 and the x plus 3 together and then you distribute the 2. All right, we're going to go ahead and multiply these 2 together first. I get x times x is x squared, x times 3 is 3x, 4 times x is 4x, 4 times 3 is 12. All with that 2 out in front. X squared, combine like terms, that's going to be 7x plus 12. And then my very last step is to distribute the 2 to everything. 2x squared plus 14x plus 24. All right, so being able to multiply that stuff out to go from vertex form to standard form or from intercept form to standard form. All right, go ahead and now, for real this time, meet me in the last video for this section.